So imagine you're routing dozens of uncompressed 4K video feeds all at once, and you need to keep your keyboard and mouse inputs completely lag-free across this massive facility.
Right, which usually takes, a dedicated server rack and an IT team working overtime.
Exactly. But today we're looking at a spec sheet from HDTVSupply for a box that just does it right out of the packaging. It's the Adder AVMC12US 12-port pre-configured matrix switch.
Quite a name.
Yeah, it is. But our mission for this deep dive is to decode what a streamlined KVM solution actually means, especially when you need, like, enterprise-level power without the crushing setup time.
And just for anyone wondering why we're focusing on KVM, that's keyboard, video, and mouse input. This hardware is really all about letting a user control multiple complex systems from one single workstation.
Which is huge for productivity. And physically, this adder switch is a 12-port unit, right?
Yeah, it gives you 10 CADX ports.
Which handle your standard high-grade copper Ethernet connections.
Exactly. But it also sits alongside 2 SFP ports. And those SFP ports are crucial because they let you slot in fiber optic connections for, ultra-fast long-distance data runs.
Okay, so it's mixing standard networking with fiber for extended range. But, I mean, the standout feature here isn't just the physical ports, is it?
No, not at all. It's the internal logic.
Right, because if you think of a standard network switch as, say, a traffic cop dropped into a brand new city.
Oh, that's a good way to look at it.
Yeah, typically they need a map, right? They have to learn the high traffic areas, and an IT admin has to program all those routes manually.
Which takes forever.
Exactly. But this switch uses auto-discovery protocols to just instantly map the network's MSC addresses on day one, so it already knows the city layout the second you plug it in.
And that pre-mapped intelligence is just essential because of the sheer volume of data it handles. I mean, without anyone writing a single command line, it natively supports IGMP version 2, IGMP snooping, and jumbo frame rates up to 9,216 bytes.
Okay, wait, let's pause on that, because 9,216 bytes is massive for a single data frame.
It really is.
Because standard network traffic is usually chopped into very small packets, right? But if you're pushing uncompressed live video, say, for a live TV broadcast control center, chopping it up just introduces lag.
Right, lag and processing overhead, and that's exactly where those jumbo frames come in.
Gotcha.
By keeping the data in these massive unbroken chunks, the video stays pristine in real time.
Yeah.
But sending data chunks that big could easily flood a network.
Oh, sure. It would just bottleneck everything.
Exactly. So that's why IGMP, which manages multicast traffic, and specifically IGMP snooping, are pre-configured here.
Okay, so how does the snooping actually work?
Well, instead of the switch just blasting that heavy video feed to every single port and causing a massive traffic jam, the snooping function kind of listens in on the network traffic.
Oh, interesting.
Yeah, it identifies exactly which port requested the video and routes that massive data payload only to that specific pathway.
Wait, if it's continuously analyzing multicast traffic and routing these massive data payloads on the fly, how does it not require constant supervision?
What do you mean?
Well, if a broadcast control center is relying on this, an unmanaged system sounds almost risky. Like, wouldn't a business need a dedicated admin monitoring a KVM management switch just to ensure it doesn't crash?
Well, you would think so, but the source material highlights that this is the core paradox of the hardware.
Okay.
It is specifically an unmanaged system. The complexity of routing those jumbo frames and managing the snooping is entirely baked into the firmware.
Wow, so it just does it itself.
Yeah, it's engineered to not need a separate management switch or some IT team constantly tweaking configurations. It relies on its internal architecture to just dynamically adjust to the traffic load.
Which means it demands incredibly low maintenance.
Precisely.
That's wild. It's handling enterprise-tier data routing, but acting like a plug-and-play consumer device.
Yeah, it really does.
I mean, for anyone dealing with IT infrastructure, whether you're outfitting a server room or a live production studio, this represents a major shift. You no longer need this deep background in computer science to reliably route high-definition video.
Right. The hardware is doing the heavy lifting for you. It completely shifts the bottleneck from the network configuration to the actual, creative or administrative work you're trying to accomplish.
Which actually brings up a really interesting dilemma for the industry.
Oh, yeah.
Yeah, think about it. If complex back-end infrastructure like KVM matrix switching is increasingly designed with this baked-in intelligence requiring minimal technical knowledge to deploy, what happens to traditional IT roles?
That is a great question.
As our hardware becomes entirely self-sufficient out of the box, we might be looking at a future where setting up a data center requires way fewer network engineers and more people who just know where to plug in the cables. Something to think about.